Welcome back, Chemistry 30. This is the last booklet in the Unit 4 section. It's 17.4 Reaction Mechanism. It pertains to 2 pages in the book. 548 to 549 is very short. And the objectives here, looking at defining complex reaction, elementary step, reaction mechanism, intermediate, and rate determining step. We'll look at understanding that many chemical reactions occur in successive elementary steps, and understand how a series of simple reactions can make up a big mechanism for a complex reaction. So first thing here, most reactions occur in which no more than 2 reactants collide. The chances of 3 or more reactants colliding correctly with the right orientation and sufficient energy likely isn't going to happen. It's like saying if you have 3 people on opposite sides of the room and if they throw a basketball at the middle, the chances of all 3 basketballs hitting each other at the same time is likely slim to none and slim left out. But 2 reactants can certainly collide, or 1 reactant can break down, etc. So that's what an elementary step is, a reaction in which no more than 2 reactants collide. Okay, question 3, I think I have my booklet out of order, so I'll have to find it. There it is. What is meant by a complex reaction? A reaction that consists of 2 or more of those little elementary steps in which no more than 2 reactants are colliding. Reaction mechanism is the complete sequence of elementary steps that make up a complex reaction. So when you have all of those elementary steps combined together, that is a reaction mechanism. Intermediates, we'll see what that is in a bit. They are little products that are produced in one step that serve as reactants in another step. So they're made and then used up soon after. And therefore, do they appear in the overall reaction? No, because they're gone. They disappear. They're only there for a short while because they get used up. So if you look at a real-life example of trying to make sense of all this, I picked the process of doing dishes. So clearing off the table, washing dishes, washing and drying, and then putting them away. So here I have 2 people clearing dishes, 1 person washing, drying, 3 people putting away. Now, as you can see, this will be the slowest step because it takes the longest. There's only 1 person washing and drying in this step. So that would be the rate determining step. How fast I'm doing dishes depends upon this, the slowest step. In order to speed up the reaction, I would have to add more people here, because adding more people here or here would not do anything. I need to add something to the slowest step in order to speed up the overall reaction. Okay, now let's see, 6b, where do I have that? I think it's over here. So here we have, looking at an example now, let's say we have this. This slide pulled from the textbook. Let's say we have this as an overall reaction, 2NO plus 2H2 yielding N2 and H2O. So here I have 4 reactants. The chances of all 4 reacting in one simple step like this is likely not going to happen. So the mechanism for that reaction is believed to be these green ones that you see. These 2 NOs break down, or they come together, and form the N2O2 molecule. Then that N2O2 molecule combines with one of these hydrogens to make N2O and H2O. Then the final N2O combines with the last H2 to form N2 and H2O. So you can see some of these things that are formed are used up in the next step. So those are the intermediates. N2O2 is produced then used. N2O is produced and used. And you'll see that you're left with 2NO plus H2O, plus H2 plus H2 gives me 2 H2s. N2, 2 water molecules. So you see I get the overall reaction here after these intermediates cancel out. And it's believed that this is a fast reaction, this is a slow one, and this is a fast one. So I'd have to give you that, and you'd have to basically cancel out the intermediates to find out the overall reaction. Graphically, we can think of it like this. 3 steps, 3 humps, 3 activated complexes to overcome. And these 2 are fast, so they should have a low hump to overcome, low activation energy, whereas this one is slow, it's going to have a huge hump. So it doesn't matter how they look, as long as relatively speaking the slowest one has the highest hump. And also reactants are here, products are here, so you can see it's an exothermic reaction. High energy reactants forming low energy products, which means energy is being released. So how do the number of activated complexes compare to the number of steps? They're the same. 3 steps, 3 humps, 3 activated complexes. How do you know how fast the reaction is going? You look at the slowest step or you look at the highest hump, because they're synonymous, same thing. Okay, next question. How do you determine the rate determining step? By looking at the pathway diagram. It's just simply the biggest bump. Okay, this one, try this one. I give you a couple of things here. See if you can cross out the intermediates and sketch what the energy pathway diagram would look like. So pause it now and see if you can try it. Okay, if you had a chance to do that, you would see that the HOBR and the HOBR cancel out. 2 HBRs plus an NO2 yields H2O, NO, and you can see we have 2 Br2s there. So we have 2 steps, 1, 2. First one's slow, second one's fast. So this one's going to be a higher hump. To indicate that that first one is endothermic, it's a positive 4.2. I need to have my intermediates higher than my reactants. So I did. Goes up and over, and the products here are slightly higher than the reactants. Then the next step, it's going to be exothermic, so my final products are going to be lower than my reactants. Still, you have to overcome the little activation energy barrier there, and then going down. So there you have it. So the first hump is higher, which means it's the rate determining step or slowest step. 2 elementary reactions, 2 humps, and you can see the endothermic part and the exothermic part. Are there intermediates? Explain why or not. If there are intermediates, what are their formulas? So yes, there are. HOBR, and they're made in one step and then used up in the second step. Okay, so there you have it. Now we just have a couple of vocab terms here, I believe, and then we're done. So complex reaction, a reaction which occurs through a series of elementary steps. So for example, this big reaction has 4 reactants. They're not all going to combine like this. They'll be broken down into steps. Elementary step, a smaller reaction in which no more than 2 reactants combine with each other. So you can see here no more than 2 things are reacting. Reaction mechanism, if I'm looking at this big equation from earlier, it's thought to be made up of these 3 elementary steps in which you see there's no more than 2 things combining. Series of steps or reactions through which a complex reaction is believed to occur. And then lastly, intermediate, the substance that is produced in one step that is used up in a later step. So back here, my N2O2 and also the N2Os from the example were the intermediates. And lastly, the rate determining step, the slowest step in a reaction, which illustrates how fast the overall thing will happen. Just think of the dishwashing thing. The slowest step in that case was the one dishwasher, so that would be the rate determining step in that one. In this one, it would be that one, the slowest step. Okay, so there you have it. That's the end of Unit 4 booklets. Hopefully we see you again. Bye-bye.